This is GATE 2016 set 2 electrical question number 52. The gain at the breakaway point of the root locus of a unity feedback system with open loop transfer function Gs equal to Ks by S minus 1 into S minus 4 is, then 4 options are given. For NPTEL reference you can refer to module 4 lecture 3 root locus plots of the NPTEL course Control Engineering by Professor Ramakrishna Pasumurthy, Department of Electrical Engineering, IIT Madras. For useful data, you need to know that the point on root locus branch will exist. Coming to the useful data, the root locus lie on the real axis on those points which lie to the left of odd number of poles and zeros together. Like for example, this is the scenario. So in this zone, the points lie to the left of odd number of poles and zeros together because only one pole. So here it is allowed. In this zone, two poles come, so not allowed because these points, left of these points, two poles are there. Here it is allowed because left of all these points, the total number of poles and zeros, that is sum of poles and zeros, are odd. So these points are allowed. So here the root locus lies on the real axis, like this. Now root locus emerges from the poles and they end at open loop zeros, that is terminate at open loop zeros. The breakaway point is the point on real axis, like for example this poles, from poles it will emerge the root locus branches and then break away. So like this, where root locus branch depart or break away from the real axis, so this point is the breakaway point, this point. Now gain at breakaway point is given by product of distance from poles of that breakaway point divided by product of distance from zeros of that breakaway point is S minus Ks by S minus 1 into S minus 4. This is Gs. So from here, characteristic equation is given as 1 plus GHS. So this is equal to 0. This is the characteristic equation, implies S minus 1 into S minus 4 plus Ks equal to 0. The numerator should be 0. K equal to minus S minus 1 into S minus 4 divided by S. dk ds equal to minus out, this should be this, differentiating this one, s square minus 5s plus 4, so a square is 2s minus 5, and then we need to differentiate s, which is 1. So if we equate it to 0, so for finding breakaway point, we do dk ds equal to 0. So now the s value will come out to be s into 2s minus 5 equal to s minus 1 into s minus 4, which implies 2s square minus 5s equal to s square minus 5s plus 4, which implies a square minus 4 equal to 0, so s equal to plus minus 2. Now s equal to 0 is a 0, so at origin 1 0 is there, and here is 1 and here is 4, the two poles. Now breakaway point can be at plus 2 or minus 2. However, we know that root locus on the real axis will exist in those regions which are left of odd number of poles and zeros together. So here is that region, it lies to the left of a region where poles and zeros are odd, and then again this region, the root locus will exist on the real axis. Now root locus emerges from the open loop poles, so like this, and it will break at this point, and like this, and here you will break in, and from pole it will march to 1 0 here, and another 0 is at infinity. So like this will be the root locus. So +2 is the breakaway point. So the distance now is 2, and the gain at breakaway point is given by product of distance from poles, which is 1 into 2 divided by product of distance from 0, which is this 1, this 2. So it is 1. Answer is 1. Option A is the correct option. Thank you.